And the second item on test number 2, not 1, we are asked to find the forces exerted on this tong, ADF, at the pin point locations at D and at F, right, as this set of tongs is holding a pipe cap that has a 45 kilonewton force on it. So let's pull off ADF as a free body. And we'll have our 22.5 kilonewtons at the top. We've got member CD, which is pinned on either end, and so it's going to be a two-force member. I'm going to assume that it's in tension. You'll see in a moment that was a pretty good choice. And down here we're trying to hold on to the pipe cap, so the pipe cap is going to push back, but it's also got to hold on to, the tong does, the pipe cap, so there's going to be a downwards force there. And we can see in a very trivial sense already here that Fy has to be equal to 22.5 by a summation of forces in the y, and that also Fx will have to equal CD by summation of forces in the x. Okay, and so now what we can do is we can apply equilibrium here to find the requested quantities. And let's note our distances that we've got here. CD is up from F at 75, and then we're going to need to get what turns out to be the distance in this force couple over here. Now that distance we've got to be a little bit careful of here. Note that to get to the center line, we've got 25 plus the 30, and then from the center line on over to F would be 45. So this total distance here is 25 plus 30 plus 45, that equals 100. And so I note as I look at that, we could, if we sum moments about point F, we're going to be able to get CD right off the bat. So let's do that. Sum moments about F. We'll take counterclockwise as positive, so we'll have a minus 22.5 times the 100, and then plus 75 times CD, set it equal to 0, and we will find out that CD is equal to a positive 30 kilonewtons. And again, the positive indicates that the member CD really was in tension, and magnitude here is of course 30. We're good to go. And we've already figured out what Fx then has to be by summation of forces in the x. We'd have minus 30 plus Fx equals 0. Therefore, Fx we wanted was 30 kilonewtons acting to the right, as shown there. And then, of course, sum of forces in the y, we've already mentioned this before. We get 22.5 minus Fy equals 0. Therefore, Fy is equaling 22.5 kilonewtons acting downwards on that particular pin. And so what we really were asked to find, though, was the magnitudes here. So F equals square root of the sum of the squares, and so that's going to be equal to 37.5 kilonewtons. So our answers here are that the magnitude of the force at D, the pin at D, is 30 kilonewtons, and the magnitude of the force at F is 37.5 kilonewtons. And note something here, that we actually have a 3-force member, right? We've got 1, 2, 3, 4 forces, but remember these acting at the same point, so really they are a single force. And since you could redraw that acting there, and so note, if you have 3 forces on a body, then they must be acting concurrently. So all we have to do is take the 2 forces where we know their lines of actions. Where they intersect is where the third must also intersect. And that tells us that that force at F actually had to run through this point that we might have called point G. And we could have used that along the way to have gotten to where we wanted to. Right? That big triangle is 100 by 75, which is a 3 to 4 ratio. And sure enough, when you look at Fy, the smaller of the two, 22.5 divided by 3 is in a 3/4 ratio, which these two have to line up along as a resultant along that particular location. So we could have used that if we'd wanted to as another way to have gotten to our final answers here of 30 kilonewtons and 37.5 kilonewtons.